Hi, Assalamualaikum, and good day to viewers. I am Faris bin Nahar, and we're about to present our group assignment of Engineering Mathematics 4, the assignment 2, and my group members are Eiman Haafizh and Mahad Abdirahman, and we are group 6, and our lecturer is TS Dr. Muhammad Afif bin Ayub. And we already find out that our problem is about a kid named Tom that walks around along a straight road from his home to a bus stop at a distance of 160 meters. And this is the graph. And after we extract this graph into a table, and this is the table. So in this point, we already decide to use numerical differentiation method as our application of numerical method in this assignment. So first of all, we need to look on the first derivative using Taylor series before we going on to the second derivative. At this point, we already constructed a table which time against velocity. So as we know, velocity is distance over time, and we decide to use our fx is 40 seconds. And from this table, you can see that the value of h, the interval between the points, is 10. H is our 10. H is 10. And from 2-point forward difference formula, we just simply put back the formula and our value obtained. And as we know, our fx is 40 and our h is just 10, and then we simply get 2 meter per second, and our error is 0. On 2-point backward reverse formula, just the same, we get our value is 2 meter per second, and our error is still 0. At 3-point central difference formula, we get 2 meter per second, sorry, and our error is still 0. Then moving on to 3-point forward difference formula, we just simply put the same value but different formula. As you can see, this is our formula, and we get 4.5 meter per second, and our error is absolute 2 minus 4.5, and it is 2.5. And at 3-point backward difference formula, we get the same answer as previous one. At 2-point, it is 2 meter per second, and our error is still 0. From this point, there is still no other parameters. It's just fx and h only. So there is no problem from our parameters and formula. So from this at this point, 5-point difference formula, we just same concept, just put back our h and fx, but the formula is this, just like this. And then we get 2.4167 meter per second, and our error is 0.4167. And then moving on to the second derivative. On second derivative, we use times again acceleration. Yep. And then this is our acceleration, but it's a bit longer. And on our 3-point central difference formula, we just the same. We use fx is 40. Our fx is 40, and our h is still 10 because no changes. And then from this formula, we obtain 0 meter per second square, and our error is 0.05. At 5-point difference formula, it is different formula from the previous one at 3-point, and the same concept. We just simply put back our obtained value, and then we get it is 0.0417 meter per second square, and our error is 0.0083. And that's all from me. Thank you very much.
Assalamu alaikum, Doctor. My name is Mahad Abdirahman Ahmed. Pattern number is B190022. I'm from Group 6. Today I'm going to present the methodology of our assignment. So first question we're going to answer is what's the suitable method to analyze it sufficiently and correctly. If we need to approximate the values of the function based on the problem, we must go to the table and graph provided and use the formula to calculate. As a result, apply all techniques of first derivative using Taylor series and all ways of the second derivative using Taylor series difference approaches are the most efficient and right methods. And secondly, how to solve the problem. Velocity and acceleration are measured using the distance and time in the graph below. So we will look at Tom's velocity and acceleration as he travels 160 meters from his house to a bus stop and on a straight road. We may use this way to determine which method is the best formula to employ on our project. This graph shows the distance in meters for Tom to walk along from house to a bus stop. And we may summarize the given data using the table format based on the above graph. So first is the first derivative using Taylor series. The second point forward difference, 2 point backward difference, third point central difference, third point forward difference, third point backward difference, and 5 point difference formula. In this situation, we will use 10 as the value depending on the difference in time values. So we can use the 2 point forward difference, 2 point backward difference, 3 point central difference, and 3 point backward difference formula to get the value of the velocity based on the computation above. As the above formula yield the smaller error value approximate to 0. We might apply the 3 point difference formula to get the value of acceleration with the second derivative using Taylor series because the formula gives a smaller error which approximates at 0.008. And we tell all the calculation in our report. So to analyze and discuss the methods, to examine and debate the techniques, we must first understand the problem's environment and the differentiation methods working. To answer all of the differentiation equations, we have two options. First, derivative using Taylor series is one of the approaches. 2 point forward difference, 2 point backward difference, 3 point central difference, third point forward difference, third point backward difference, and third point difference formula are among the first derivative differentiation orders. Another is second derivative differentiation, which includes a third point central difference as well as a 5 point formula difference. The requirements in our assignment, which were derived from electrical engineering problem, will next be examined and analyzed. In this project, we must determine a specific point of value using genuine data obtained from the internet. We have used up to 6 different formulas to approximate the value. For example, the first derivative of second point forward difference formula is given there. Then we put all the data given to the formula. When we get an answer, we calculated the error by utilizing the formula to see if the value is 0 or close to 0. Thank you, Doctor.
Assalamualaikum, Doctor. And my name is Eiman bin Jafri. My metric number is CA190149. Firstly, I want to sorry about why I didn't appear my face because my cam is broken, corrupt. I don't know why. So this video will only appear my voice. So I will present about 3.0 result in discussion. So for 3.1, what are your results? So basically for this mathematical problem, we use the first derivative using Taylor series method and second derivative Taylor series method. So for the first derivative Taylor series, where we use 6 type of differences, is 2 point forward, 2 point back forward difference, 3 point central difference formula, and 3 point forward difference, 3 point backward difference, and 5 point difference formula. So each formula appear same result and different result, where for the same result is appear for the answer is 2. Meanwhile, there are 2 types differences, is 3 point forward differences and 5 point different formula, where appear a different answer. So next is for the second derivative using Taylor series method, where we use 2 types. Is for first is 3 point central differences and 5 points differences. So the 3 point central differences appear 0, and 5 point differences, the answer is 0.0417. So for 3.2 is what you're finding is, we find for the first derivative using Taylor series method has the smallest absolute error value. So for the second derivative using Taylor series method is show that we got the smallest absolute error value 0.0083. We show the value is having the closest approximate value of 0.0417 millisecond. So why we get this result? So there are few formulas for diversity using Taylor series method, and we typically represent the solution as a discrete exponential that is defined on a graph. So basically is to compare this all the 6 formula from first derivative using the Taylor series method. We repeat the calculation using the remainder formula for t equal to 40 second as the x value to get the approximate value. So for the second derivative is almost the same as the first derivative, but it's a bit complicated. The approximity is slightly different from the first derivative because it contains just 2 formula. So by using the data tabulate, we must create another table for acceleration, ms and times by using the same x value. We use the 3-point central and 5-point difference formula to find the acceleration. Upon getting the value, we then check the errors to get value of the absolute error. Hence we got the suitable formula to use the find acceleration. So for the 3.4 is why we get these findings. So as a result, now we know that Taylor series for function, we can extract from it any derivatives of the function. So using the both method, first derivatives using the series and second derivative produce almost the same answer because we are using approximation method, and for sure the answer obtained will be also approximations. So next is comparing the efficient method to solve numerical differentiation problem. So the first derivative using Taylor series method is much more efficient than second derivative using the Taylor series method, because in first derivative using Taylor series method, the calculation is more stable as has multiple formula to use to solve the problem. This method is more efficient to solve the problem. So that's all from me.